Alright, this video is most likely being shown in my room because I have a sub, and it never hurts to get some practice at converting things, so I made up 9 problems that we're going to solve together. So here we go. 45 feet equals how many inches? Yeah, this one is pretty simple. You guys in your heads are probably already working this one out, but to do this problem, what do you need to know? You need to know that 1 foot is 12 inches. And when we do conversion problems and we're using what's called dimensional analysis, we can write this equality. We can write this equality 2 different ways in our fractions. We can write it like this, 1 foot over 12 inches, or we can write it like this, 12 inches over 1 foot. So if we write it this way, then we're probably trying to cancel out inches and go to feet. And if we write it this way, we're probably trying to cancel out feet and go to inches. But either way, just remember that the value of this fraction is 1, no matter which way you write it. Because 1 foot, since it's the same thing as 12 inches, that means this fraction is equal to 1. And the same thing goes for this one. 12 inches is the same thing as 1 foot, so that equals 1. Okay, so let's get back to business here. The first thing you do is you write your given quantity, 45 feet. You don't have to, but it's good practice to put that over 1. It just reminds you that any number can be a fraction. And then we are going to multiply by something that allows us to cancel out feet. So since I have feet on top and I want to cancel it out, I put feet on bottom. And in this case, I was asked for inches, so I'm going to put inches on top. Now I just have to decide whether I'm going to use this one or that one. Well, since I've got feet on bottom, I'm going to pick this one. So I'm going to write 12 inches over 1 foot. And just for a second, let's say I did this wrong. Let's say that I put the 1 there and the 12 there. What would this sound like if I read it out loud? 1 inch equals 12 feet. That should sound goofy. So that's one good way to know that you've done something wrong. So 12 inches is 1 foot. So our feet cancel out, and all we have to do to get our answer is go 45 times 12, and that is 540. So there is problem number 1. 540 what? Well, since feet canceled out, it's inches. There we go. So next one. This one is the same problem the other way. 45 inches is how many feet? So just following our practice here, we write what we were given, put it over 1, and we're going to multiply by a fraction. And this time, we've got inches on top, so we're going to put inches on bottom, so that way they cancel out. I won't do that just yet. And if we're getting rid of inches, we're trying to go to feet. And so I've got to decide what numbers to fill in here, so I can go back down here and say, oh yeah, I've got 1 feet. Did I just say 1 feet? Oops. 1 foot is 12 inches. 12 inches is 1 foot. So if I just say it out loud, 12 inches is 1 foot. That's the way you do it. If I'd have done it the wrong way, it would say 12 feet equals 1 inch, and that would sound goofy. But anyway, we cancel out our inches. And this time, what we've got is 45 and 1 on top. And we've got 1 times 12 on the bottom. So this time, it's going to be division. So we'll go 45 divided by 12, and we're going to get 3 3/4, so 3.75. What was that again? Inches canceled, so our answer was feet. So 45 inches is 3 3/4, 3.75 feet. 2 down, 7 to go. Here we go. This one, I threw this one in, even though it's easy, I threw this one in because quite often when students see this, they see the little squares here, they instantly freak out. They're like, oh my gosh, this problem is so hard. No, it's not hard at all. That squared up there is just part of the unit. Just as kind of a little side lecture here, if you've got something that's 1 foot long, and then you've got something that's 1 foot wide. Let's say that we've got like a floor tile, like the floor tiles in my classroom. They're 1 foot by 1 foot. So if you want to know what this area is, you just multiply those two together. 1 times 1 is 1. So this area is 1 foot squared. But we don't have to measure it out in inches. We could measure this out. I'm sorry, we don't have to measure this out in feet. We could have measured it out in inches. So one side here, 1 foot, it's 12 inches by 12 inches. So this whole area, it is 1 square foot, or 1 foot squared, but it's also 144 inches squared. So don't let these little squares scare you. All they are is part of the unit. I have seen kids that they'll come up to me and they'll say, so once I get my answer, do I have to square it because that little 2 is there? I'm like, no. You don't have to. That's just part of your unit for your answer. It's a good question, but you don't have to. So let's solve this one then. So I've got my 162 square feet, or feet squared. I'm going to put it over 1. And I want to get rid of square feet, and I want square inches. So what I figured out up here was that 1 square foot is 144 square inches. So this gives me my equality. Remember, I can write this either way. I can write it 1 foot squared, or 1 square foot over 144 inches squared, or I can write it 144 square inches, or inches squared, over 1 foot squared. So I'm going to pick one of these two to do this problem, and look, I've got feet on bottom, inches on top, so I'm going to pick this one. 1 square foot is 144 square inches, so that is going to give me an answer of 162 times 144, and I get 23,328. So 23,328, and feet squared, or square feet, canceled out, so that is square inches. All right. Should you be surprised when you get a relatively big answer for a number, you know, over 20,000? Well, not really, because think about 162 square feet. You know that a square foot is quite a few square inches. So if we're going from a big unit like a square foot to a smaller unit like a square inch, we should get a bigger answer. All right, so next problem, moving on. What did I make here? Oh, I did the same kind of problem in the reverse order, so let's just do that. Let's go orange this time. 162 inches squared over 1, just because that's our procedure. We want to get rid of square inches, so they go on bottom, and we want square feet. They go on top. And what did we say? We said that 1 square foot was 144 square inches. So this time we've got 162 times 1 on top. That's 162. And 1 times 144 on bottom. So our answer is going to be 1 point something, isn't it? Let's see here. 162 divided by 144. We get 1.125, or 1 1/8. So that's 1.125. And what unit would that be in? That would be in, remember what canceled out here? Square inches canceled out, so our answer is 1.125 square feet. I didn't leave myself much room there. All right, so let's see what's next. Liters to gallons. So liters, that's a metric unit. And gallons, that's a US unit, or you could call it a standard unit, but it's not really standard because not many people use gallons anymore on this planet. Anyway, to get this problem right, you need to know how many gallons are in a liter, or how many liters are in a gallon. So I'm going to pick the bigger of the two. Gallons are bigger, so I'm going to say that 1 gallon, and that equals 3.79, more or less, 3.79 liters. I could do it the other way. I could say that 1 liter equals 0.26 gallons. You know, either way, I could use either one of these, and they're fine, pretty much. I mean, I'm not worried about too much rounding here, but I think I'm just going to stick with using this one. So anyway, this problem is just like the other ones we've seen. You write down what you were given, 7.63 liters, put it over 1. We want to get rid of liters, go to gallons, and let's see here, 1 gallon. So why did I draw this long dumb arrow? Who knows? Well, what's going on here? So 1 gallon, 1's going to go there, and our 3.79 liters, that's going to go here. So we're going to have 7.63 times 1. So on top we got 7.63, and on bottom we've got 3.79. So what's our answer going to be? A little less than, I don't know, somewhere around 2-ish? So let's see here. 7.63 divided by 3.79, we wind up with 2.01. So 2.01 what? Well, liters on top, liters on bottom. The only unit left is gallons. So 2.01 gallons. Let's keep moving. Next problem. Okay, so if I've seen students freak out about seeing that little squared up here, I have certainly seen students freak out about seeing this cubed here. And there's no reason to freak out. It's just part of a unit. It's a conversion. I'm getting ahead of myself. It's just a unit. We don't have to freak out about seeing the 3 here. Let me just take a little side lecture here and explain to you what this is. So if we've got a line that is 1 yard long, that means that line is also 3 feet long, right? So if I have a flat surface that is also 1 yard on its side, that's 3 feet. So we know that this area here, if we were doing area, it would be 1 square yard, or it would be 3 times 3, it would be 9 square feet. But this one's got this cubed here. So I'm not talking about square units, I'm talking about cubic units, which is volume. So instead, I've actually got this 3D box. It's 1 yard left to right, 1 yard up and down, and 1 yard front to back. And that's 3 feet front to back. So now that if we multiplied yards times yards times yards, we get 1 cubic yard. That's how big this box is. How big would this box be in cubic feet? Well, we would go 3 times 3 times 3. So 3 times 3 is 9, 9 times 3 is 27, so 27 cubic feet. So 1 cubic yard is 27 cubic feet. So now let's just do this problem. We got 1,096 cubic feet. Put it over 1. We want to get rid of cubic feet and go to cubic yards. So what have I got here? I've got cubic yards and cubic feet. So I want my cubic feet number, which is 27 on the bottom, and my cubic yard number, which is 1 on top. So I'm going to have what? I'm going to have this number divided by that number, and what's going to cancel out? My cubic feet are going to cancel out, and I'm going to be left with cubic yards. And why did I put a square there? Hasty. Okay, my software's messing up, but trust me, that's a 3. So without actually writing the fraction, what have I got? I've got my 1,096 on top divided by my 27 on the bottom, and I wind up with 40.59. So 40.59 what? It is going to be cubic yards. That is so weird. Anyway, yards cubed. So just one last time, let me say it. When you see this feet cubed or yards cubed, no, you don't have to cube your answer or take the cube root of your answer or anything. It's just part of the problem. It's just a conversion factor. It's just the unit that goes with the number. Okay, so let's see here. What do we have here? Oh, some scientific notation. Hopefully we don't have a sub that early in the year that you haven't seen this already. But let's do this here. Times 10 to the 11th. What is that? Well, 10 to the 11th. That's 10 times 10 times 10, 11 times, right? So basically what we're doing here is we're taking a ginormous number. This is 31 times 10 to the 11th. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Who wants to write this? Nobody. So this is what we do. We write 31 times 10 to the 11th kilometers over 1. It's just the same as any other problem. And I want to get rid of kilometers and go to meters. So to solve this problem, what's the conversion factor I need to know? I need to know that 1 kilometer is 1,000 meters. And how can I write that? who cares how I write it? I know this now, so I'm just going to go 1 kilometer. That's going to go here. And 1,000 meters, that's going to go there. So on my calculator, what do I have to do? I've just got to go 31 times 10 to the 11th times 1,000. And I get this crazy number that I don't want to write. So on the Windows calculator, if I hit this button right here, beep, I go, oh, okay, so my answer is 3.1 times 10 to the, what was that? It was 15th. And this E right here, that's just the calculator's way of saying times 10 to the, so times 10 to the 15th what? Kilometers canceled, so our answer is in meters. Okay, so scientific notation, when you have a very nice calculator, not a big deal at all. Okay, so next. What in the heck is going on here? This is just another metric problem. I'm just going to write down what I was given, 0.009 millimeters, and I'm going to put that over 1. I'm going to get rid of millimeters, and this might be the first time you've seen this thing before. This is a micro prefix, so we're going from millimeters to micrometers, or a lot of people say micrometers. So what do we need to know here? Don't be scared by a weird looking unit, but all we need to know is that 1 millimeter is 1,000 micrometers, and we can just fill it in just like before. Put the 1 by the milli, which would be right there, and put 1,000 by the micrometers right there. And so this problem is pretty straightforward. We've got 1s on bottom, so we're just going to ignore them. Milli is going to cancel out, so what do we wind up with? We wind up with micrometers, because millimeters canceled out. So 0.009 times 1,000, if you multiply by 1,000, you could use a calculator, but all you do is slide the decimal 3 places to the right, and we wind up with 9 micrometers. Okay, 1 problem to go. Okay, same sort of problem, it's just this time I stuck on a negative exponent, just in case anybody was not knowing how to do that or haven't seen that before. So I'm going to write down what I was given, 3 times 10 to the negative 7th micrometers, put it over 1. I'm going to get rid of micrometers and go to millimeters. And from the last page, we saw that 1 millimeter is 1,000 micrometers, so 1 millimeter is 1,000 micrometers. What's that going to cancel out for us? That's going to cancel out micrometers, so they'll be gone. And what do we do here? Well, we've got this on top and this on bottom, so we're just dividing. Now, maybe you remember the scientific notation rules. If you're going to divide by a number, then you're going to slide the decimal to the... Anybody know? Anybody remember? What's this? 1,000, that's 10 to the 3rd, right? So we're taking negative 7th divided by negative 3rd. What do we do there? We subtract, don't we? So negative 7 minus 3 is negative 10th. So I think my answer is going to be 3 times 10 to the negative 10th. What? That's going to be millimeters. And if you don't trust me, let's really quickly just blast it out on the calculator. So we've got 3 times 10 to the negative 7th divided by 1,000. And we get this, and I don't want to count those zeros, so I'm going to hit this button, and you get 3 times 10 to the negative 10th. So there you go. There are a bunch of 9 conversion problems, just under 20 minutes. We made it.